Hello. So, for this question, right, what they're asking you to find is, okay, what they're telling you is they give you the area of a triangle. The length AB is 18.7, the length BC is 12.8, and they're asking you to find the two possible sizes of the angle ABC. I hope you can see the ABC is really just the angle that's in between the two lengths. Now, how can it be? How can it be? You're asking yourself. There's only one triangle. How come we'll have two possible angles? That's when you need to be a bit creative and realize that, hey, when do you get to have two angles? When do you get to have two angles? When you are trying to solve, let's say, sine theta equals to like 1/2. Do you only get one angle, like 30 degrees? Only? No, right? There's also the obtuse angle 180 minus 30. Remember? So this when you do solve sine, you will get two possibilities. Okay, cosine and tangent as well, but sine is more relevant to this question. If you understand this concept, then now you need to interpret it in terms of a diagram. What if both of these answers are actually possible? Okay. It's just that you need to consider both cases. You cannot reject both answers. You cannot reject one of the answers and keep one of them, but instead you need to keep both of them and consider both cases because not enough information is given. Would that be possible? Yes, that would be possible. That's exactly what this question is telling you. They only gave you area and two lengths. It's not enough information to specify what is the specific angle. So that's when you have to get a bit creative and realize that, if this is one possible triangle with an angle that's like this, how about this other possibility where, remember, how do we get the other angle? We had to take 180 minus, right? 180 minus. So I purposely draw my angle theta here along a horizontal line. And what do you know about angles on a straight line? They add up to 180 degrees, right? So maybe this supplementary angle here will be the other version of theta. Can that be the case? Yes. Let's try. Let me show you. So black length here. You need a theta over here, the second version, but you need the blue length. But the blue length is currently on the left. I need it on the right side. So what can I do? Very simple. Shift it over, like this. But of course your labeling must move over as well. So point B will be here, point A will be here, theta 1 no more, 18.7 still remains, 12.8, maybe I just shift it to the other side so it's easier for me. This gray length disappear. This one don't call it C1 anymore, call it C2, version 2. And then I draw a line connecting them together like this. Okay, maybe I make it a bit thicker and gray. Can you see? This angle here, theta version number 2. You can, if you want, you can put it side by side like this. Oh, you see, so nice. It fits nicely on a straight line, right? The theta 1 and theta 2. This is the second version of the triangle that they are looking at. Okay, the theta could be an obtuse angle as well. But all this is really just a picture. If you want to solve for theta, what you need to realize is that there is a formula for finding area of a triangle. And even if you couldn't visualize this, and if you know the formula, you can actually solve this question. The area is really of a triangle is really just half AB sine theta, right? Remember this formula? How do I know I need to use this formula and not half times base times perpendicular height? Because I see that there's an angle. I know that two possible angles must involve sine or cosine or tangent. And I also know that this angle here happens to be what? Happens to be included in between the two sides. Happens to be what? Happens to be included in between the two sides. Same thing here with the formula for half AB sine theta. The A and the B, length A and length B of the two sides, they must be the two sides must be sandwiching the angle theta. Okay, they must be surrounding the angle theta. Or in other words, the theta angle here has to be included in between two lengths. Okay, so if you remember this rule about the angle theta having to be included in the half AB sine theta, then immediately you'll think, oh, I can use this formula for this question. Okay, I hope that makes some intuitive sense. Okay, but anyways, now we just need to use the formula. So in this case, we know that the area of the triangle is 58.6. So 58.6 is equal to half times A, which is 18.7, B, which is 12.8, order doesn't really matter, multiplied by the sine of a theta. What do you think we want to do with this theta now? Solve for theta now? Okay, very good. So we'll just make sine theta the subject. 58.6, you can divide over by the half times 18.7 times 12.8. Type it in the calculator and you get, let me see. Be careful of the half on the denominator. And you will obtain 0.489639. Okay, good. Solving for theta. Now in this case they are using, did they specify the units? Okay, they didn't specify whether they want degrees or radians. So just use degrees, I think that's easier. So just take the sine inverse of that answer. And what do we get? We get a basic angle. If you did A max, you'll know this. 3168 degrees, or the other angle will be, what would it be? 180 minus, because quadrant 2, right? Of course in EMath you just need to memorize this for the obtuse angles. Then you just take 180 minus and you get 150.683 degrees. Okay, rounding off, you get 29.3 degrees as 1 dp, and 150.7 degrees 1 dp. Sorry, I should make a approximation there and equal, approximation there and equal. Okay, and then we are done. Just remember, always round off to 1 dp for angles, in degrees, but for radians will be 3SF. Okay, that's it.